We are going to be using linear algebra to put our systems into a state space form of our model in a couple of sections, and this is going to involve matrices as part of that linear algebra. So we want to make sure that we're able to put our series or our system of linear equations into a matrix form. So what we are going to want to do is take our system of equations and make sure that we get everything into this consistent form where we can rewrite them such that any purely constant term is going to be on the right-hand side, and the left-hand side is going to have all of our dependent variables in the same order. And then what we're going to be looking at is what are the coefficients in front of each of those dependent variables. So we're going to write it first into that standard form. Then we can see that we're going to be able to rewrite that system of equations in a form that looks like ax equals b, where a is a matrix, x is a vector, and b is a vector. So we want to take our system of scalar equations and rewrite it as one matrix equation. So x is going to be our vector of dependent variables that we established when we rewrote everything in the standard form. B is going to be a vector made up of those right-hand sides, those constants that we have for each of our equations once it's in that standard form. And maybe a right-hand side is 0. That's okay. That will be its entry in this B vector. And then we are left with this A matrix. The A matrix is going to be composed of the coefficients that were in front of our dependent variables on the left-hand side. So what we're going to see is that each row of A is going to correspond to one of our scalar equations. The same is true with B. Each row of B corresponds with one of our scalar equations. And then each column of A will correspond to one of our dependent variables. So as we'll see in the next example, if our dependent variables, let's say, are x, y, and z, we want to make sure that the left-hand side of all of our scalar equations is in that same order, x, y, z. So then each column of A will be, the first one would be the coefficients in front of the x for each equation. The second column would be the coefficients in front of the y for each equation. And the third column would be the coefficients in front of z for each of those equations. Then we have it as this matrix form where, in that case, we would have a 3 by 3 matrix if we had 3 equations and 3 variables. A would be 3 by 3, x would be a column vector with 3 elements, and b would be a column vector of 3 elements. We're going to be dealing with systems where we have the same number of equations as we have variables in this course. So A is always going to be square, x and b are always going to be column vectors in this case.